Good morning, friends. I, Dr. Devis Pandil, Associate Professor, Suraj Gyan Vihar University, that is accredited by NAC A grade. Today, I will discuss about how to insert node in BST. How to insert a node in binary search tree. I am presenting my screen. I hope you can see my screen. Today, Today I will discuss about how to insert a node in your binary search tree. You know, this is the topic of your data structure and algorithm, and if we will discuss about the object and outcome of this lecture. So through this binary search tree, the object of this lecture is your how to insert the binary search, how to insert a node in your binary search tree. And if we will discuss about the outcome of this lecture, after studying this lecture, student will able to how to insert a node in your binary search tree. And now, you know, during this lecture, I will cover so many topics like your object and outcome. You know, if you are inserting a node in your binary search tree, so you should know about the binary search tree. That's why in this lecture, I will give the overview of your binary search tree, and also I will mention the how to represent the binary search tree, and also I will explain the I will explain and only give the only overview basic operations of your binary search tree. After that, I will discuss about the algorithm, ki how to write the algorithm for insert the node in your binary search tree. And after this, I will mention some questions which are related from this lecture. So now I will discuss about the binary search tree. You know, in your binary search tree, in my past lectures, in my previous lectures, I had already discussed about the binary search tree. And in this lecture, I will discuss about how to insert a node in a binary search tree. So when you are inserting a node in your binary search tree, so you should know about the concept of your binary search tree. That's why here I am giving the overview of your binary search tree. You know, binary search tree is a tree which all the nodes follow the below mentioned property. And all properties I have mentioned. First property is that the value of the key of the left subtree is less than the value of the parent node. You know, if here I am discussing about the binary search tree, so your left subtree value always less than from your the root node in your binary search tree. And if we will talk about the second property, the value of the key of the right subtree is greater than or equal to the value of your parent, that is your root. So your first property is that the value of the subtree is less than from your root value, and the second property is that the value of your right subtree is greater or equal to the from the root value. And thus BST divide its all subtree into two segments. the left subtree and the right subtree. And if you want to define, you can define as left subtree less than node less than equal to right subtree. That is the relation between left subtree, root, and your right subtree. Because as per I had told, in your binary search tree, the left node value is less than from your root value, and your right subtree value is greater than and greater than equal to from the your root value. So these are the all sub property. And if you want to define the relation between your left subtree, root, and your right subtree in your binary search tree, so you can define this statement: your left subtree value is always less than from your root value and less than equal to from your right subtree value. Here I had represented a binary search tree. You can understand from this slide. Your first node is your 27. The first node value is your 27. And your left subtree value is your 40, and your right subtree value is your 35. Your 14 is less than from your 27, and your 35 is less than from your, sorry, 35 is greater than from your 27. And in the same manner, 10 is the left subtree value is less than from your root, and 19 is the right subtree value that is greater than from your root. In the same manner, your 31 is less than value from your 35, and your 42 is greater than the value from your 35. And now I will discuss about the basic operations. In my past lecture, I had already discussed about the basic operations of your binary search tree, but in this lecture, your this lecture is totally based on how to insert a node in a binary search tree. That's why here I am giving the overview of your basic operations of your binary search tree. That is your BST. Your first operation is your search. Search operation is that for when you want to search the any node in your tree, that is your search operation. And insert a element in a tree, that is your insert operation. And your remaining operations are pre-order traversal, in-order traversal, and your post-order traversal. Okay, so your these are the five basic operations of your binary search tree. First is your search, second is your insert, third is your pre-order traversal, fourth is your in-order traversal, and your post-order traversal. If you want to search the any node in your binary search tree, so you will apply the search operation. And in the same manner, if you want to insert the any node in your binary search tree, so you will apply the insert operation. And your remaining three operations are your pre-order traversal, in-order traversal, and your post-order traversal. Pre-order traversal means when you will traverse in your pre-order manner. Okay, pre-order manner. And if we will talk about the in-order traversal, when you will traverse the in-order manner, when you will traverse the order manner, that is called the post-order traversal. In my past lecture, I had already discussed about the pre-order traversal, in-order traversal, and your post-order traversal. That's why here is no need for describe the pre-order, in-order, and your post-order. Okay, and now node. When you are inserting a node in your binary search tree, so first of all you should know how to create a node, because after creation node you will insert the node in your binary search tree. So you will define a node having some data reference to its your left and your right child nodes. Okay, when you will create a node, you will create a node through the structure, through the struct. Your struct is the keyword of your structure, and your opening braces, first of all you will take the data, and after that you will create the two pointer. Your first pointer is your left child pointer, and second pointer is your right child pointer, because as per I had told, in your binary search tree, your binary search tree is divided into, your first is your left subtree, and second is your right subtree. Okay, and here I am discussing about how to insert a node in your binary search tree. That's why, first of all, I have to create a node through the structure, through the struct keyword, int date, and I have taken a data of integer type, and I have taken the two pointers. First pointer is your left child pointer, and second pointer is your right child pointer. That's why I had mentioned struct node left child pointer type and your struct node right child pointer type, and after that your braces will be end. And after that I will discuss about the insert operation. Insert operations means when you will insert the data, when you will insert the node in your binary search tree, that is your insert operation. Whenever an element is to be inserted, first locate is to its a proper location. Means when you will insert a node, so first of all you will indicate, you will decide it, your inserted node which take the position. That's why I had told first locate its proper location, and start searching from the root node. Then if the data is less than, because if you will insert a node in your binary search tree, so first of all you will search from the root node. If your inserting node value is less than from your root node, obviously your node will be insert in your left hand side from the root. And if your inserting node value is greater than from or equal to the from the root node value, so your inserted node will insert in your right side subtree. That's why you will start the searching from your root node when you want to insert the node in your tree. So start searching from the root node. Then if the data is less than the key value, search for the empty location in the left subtree and insert the data. Otherwise, search for the empty location in the right subtree and insert the data. That is your insert operation. In your insert operation, you will focus, if you want to insert the any other node in your BST, so your searching should be start from your root node. Okay. If your inserting node value is less than from your root value, so your node will be insert in your left side of your from your root. And if your inserting node value is greater than from your right root node, so you will insert in your right side from your root node. And you will write the algorithm for insert the node. First of all, create a new BST node and assign value to it. Here BST means binary search tree. So first of all, you will create a node, because you want to insert the new node in your binary search tree. So your first step is that you will create the node and assign value to it. After creation the node, you will assign the value. to this node. Okay, and in your second step, you will make a function for your insert node, and in your insert function, you will take the two parameter, your node and your key. And in your first step, when you will insert a node in your binary search tree, in your if root equal to null, return the new node to the calling function. That is the condition. If your root equal to null, so return the new node to the calling function. And in your second step, if your root greater than data is less than from your key, so call the insert function with root with root pointer to the right and assign the value in the root pointer to the right. This is the possible when your inserting node value is greater than from your root value, because I had already told about that. If your inserting node value is greater than from your root value, that time your new node will be insert in your right side of your root node. And if your inserting node value is less than from your root node, that time your new node will be insert in your left side from your root node. So in your third step, if root point to the data greater than your key, to call the insert function with your root access to the left and assign to the value in your root left. Okay, that these are the three steps. In your first step, your if your root equal to the null, return the new value to the calling function. And in your second step, if your root data is less than from your key, to call the insert function with root right. And if your data is greater than from your key, to call the insert function with root access the left and assign the return left value in the root left. Okay, and finally return the original root pointer to the calling function. This is the algorithm for when you want for insert a node in your binary search tree. You know about the algorithm. Algorithm is just nothing. Algorithm is just only step by step instructions. When you will implement the any technique, so implement before the implementation a technique, if you will write the algorithm, so you can implement this technique in any programming language in your simple manner. And if you don't write the algorithm before implementing the technique, so definitely you will face the problem when you will implement this technique in any other programming language. That's why your algorithm is your compulsory. In your algorithm there is no any foundation. If first of all you will write only this instruction, after that you will write only this instruction, after that you will write only this instruction. Only in your algorithm, only you will write the instruction in your step by step for achieving a goal in your sequential manner. That is your algorithm. And now implementing as per I had told you, first of all you will create your node, struct node, and your insert. And first of all you will take the root value and your value if the handle two cases. Okay, first cases is that if the tree is empty, return new node in the root. Suppose if your tree is your empty, means your tree is blank, means there is no any node in your tree. And that time if you will insert a node, so your return your new node in the root node. And if the tree traversal reaches null, so it will return the new node. If root equal to the null, so return the get new node value if value is greater than from your root. Okay, and we should find the correct place in the right subtree and insert the new node, because as per I had told, if you will insert a new node, so your new node value will be compared, first of all search from the root. If your new node value is less than from your root node, always your new node will place in your left hand side from the root. And if your new node value is greater than from your root node, so that time you will insert in your right side from the root node. And we should find the correct place in the left subtree and insert the new node. And if your key is greater than your value, as per I had told, so you will calling the your insert functions, and it will handle two cases: prevent the duplicate nodes in the tree. And if your root will access to the key equal to value, so it will straight away return the address of the root node. And in your second step, after the insertion, it will return the original unchanged root's address. And now I am discussing about the example of your searching operation. Always you will start from your root and compare the searching element as per I had told with the root. If less than from your root, the recurs for left, else recurs for your right. And in your third, if the element to search is found anywhere, return true, else return false. You can see here in your binary search tree, your first your root node is your 8, and your 3 is the minimum 3 is the less than from your 8. That's why I have placed in your left hand side your subtree. And your 10 is the place in your right side subtree, because this value is greater than from your 8. And only I had follow only this technique when you will insert the node and when you will search the node in your binary search tree. And example of your insert key, a new key is always inserted at the leaf. If we will talk about your leaf node, if we will talk about your leaf node means leaf node is the node who have no any branches. This is your leaf node. Okay. And a new key is always inserted at the leaf node. At the leaf, we start searching from the key from the root as per I had told, until we hit a leaf node. Once a leaf node is found, the new node is added as a child of the leaf node. Because when you want to insert the new node in your binary search tree, always your new node will be inserted at your leaf node. Okay. And always your searching will start from your root node. Okay. And now as per I had discussed, there are three remaining operations of your binary search tree, like your in-order traversal, like your pre-order traversal, and like your post-order traversal. If we will talk about the in-order traversal, so in your traversal, first of all, you will visit the left subtree, and after that you will visit the root, and later that you will visit the right subtree, and that is your in-order traversal. And now, if a binary tree is traversed in order, the output will produce sorted key value in your ascending order. as per I had discussed about your in order traversal. Your in order traversal. First of all, you will visit your left subtree. After that, you will visit the right subtree. After that, you will visit the root node. After that, you will visit the right subtree. Okay. So if you will follow the in order, so your always when you will traverse, so you always your traverse in your ascending order, because your in order, first of all you will visit your left subtree, that is the value is less than from your root node. After that you will visit the right root node, and after that you will visit the right subtree. You can see here. And here, first of all, you will visit the left subtree, after that root, after that your right subtree. I mean, first of all, you will visit traverse the V node, after that you will traverse the A, after that you will traverse the C. And now second is your, you can see here, we start from A and following in order traversal, we move to its left subtree B. V is also traversed in your in order. The process goes on until all the nodes are visited. The output of in order traversal of this tree D, B, E, A, F, C, G. You can see here. First of all, D, B, E, A, F, G, F, C, and G. Okay, and next is that algorithm for in order. So first of all, you will recursively traverse the left subtree. After that, you will visit root node and recursively traverse the right subtree. That is the algorithm of your pre-order traversal. And the second is your your pre-order traversal. In this traversal method, the root node is visited first, then the subtree, and finally the right subtree. Means in your pre-order traversal, first of all you will traverse the root node. After that, you will traverse the left subtree. After that, you will traverse the right subtree. That is the pre-order traversal. And you can see, first of all you will traverse the root node. After that, you will traverse the left. After that, you will traverse the right. I am not going in your depth of your pre-order traversal, in order traversal, and of order traversal, because I had already discussed about these uh, three traversal in my past lectures. I think there is no need for describing it. And you can see here, in your pre-order traversal, first of all you will visit your root node. After that, you will visit the left subtree. After that, you will visit the right subtree. And next is that algorithm, until all nodes are traversed. First of all, you will visit root node. After that, recursively traverse the left subtree. After that, recursively traverse the right subtree. And finally, in your last, your post order traversal. In your order traversal, the root node is visited the last. First of all, you will visit the left subtree. After that, you will visit right subtree. After that, you will visit the root node. You can see here in this slide. And here, first of all, you will visit the left subtree. After that, right. After that, your root. So first of all, in your when you will start from your top level, your level 0. So first of all, you will visit the B. After that, you will visit the C. After that, you will visit the A. And in your level second, first of all you will visit the D. After that, E. After that, B. So your path is that D, E, B, F, G, C, A. You can see here. You can see here. We start from A, the following post order traversal. B first visit the left subtree. B also traverse post order. The process goes on until all the nodes are visited. The output of post order traversal is this: D, E, B, F, G, C, A. This is your post order traversal. And the algorithm for the post-order traversal recursively traverse the left subtree, after that traverse the right subtree, and in your last you will visit the root node. This is your post-order traversal. And you can see here example in your in order, left, after that root, after that right, and in your pre-order root, left, and your right, and your post-order left, right, and your root. And you can see here, as per I had discussed key in the end of this lecture, I will discuss about the some questions which are related from your binary search tree, from your tree. In this question, your 2 is your root node, 7 is to be placed in your left subtree, 5 is placed in your right subtree, and in your this is your level 0, level 1, level 2, and level 3. And in your level 2, 2 is placed in your left subtree, 11 is placed in your right subtree, and 9 is placed in your right subtree from your root node 5. Means this is your tree. And if we will follow the in order traversal, so in order traversal you will follow. See your in order traversal, in order traversal, first of all you will visit the left subtree, after that you will visit the root node, after that you will visit the right subtree. According to this, your answer will be your A. Your 6 2 5 7 11 2 5 9 4. B answer 652117495 and your C answer 27265115594 and your D answer 276511295. This is your last option. If you will apply the in order traversal, so your answer should be 62571125594. You can see here. That's why your answer will be your A answer. And again, I have mentioned in this slide your another tree, and you will find, as per question, level order traversal. In your level answer 27521196554. You can see here, and you can find from this tree. And after that, what is the space complexity of the in-order traversal in the recursive fashion? D is the tree depth and N is the number of your nodes. Your first option is your 1, N log D, and your D. So your answer will be your D. That's why your answer is your D. And that is the space complexity of the in-order traversal in the recursive fashion. And now, what is the time complexity of level order traversal? First option is your 1, second option is your n, third option is that your log n, and fourth option is that your n log n. That's why your answer will be your B answer. That is your n. Okay, your one is the not the time complexity of your order traversal, not a log n and not a n log n. That's why your answer will be your n. Which of the following graph traversal closely imitates level order traversal of a binary tree? Depth first search, breadth first search, depth and binary first search, and your binary search. Graph traversal closely imitates level order traversal of a binary tree. So your graph will be your breadth first search, that is your BFS, not a DFS, not a depth first search. Your graph traversal closely imitates level order traversal of binary tree, that is your breadth first search. That's why your answer will be your B answer. And now, in a binary search tree, which of the following traverse would print the numbers in the ascending order? level order traversal, pre-order traversal, post-order traversal, and your in-order traversal. Your answer is your in-order traversal. Because in a binary search tree, which of the following traversal will print the number in your in ascending order? And I had already told, if you will traverse the tree, so your traversing value will always in your ascending order, in your in-order traversal, because your in-order traversal, first of all, you will visit the left subtree, and your left subtree value will less than from your root node, and your right subtree in your right subtree value will always greater than, always equal to greater than from your root value. That's why if you will traverse in order traversal, always your traversing value will be in your ascending order. So your answer will be your in order traversal. That is your D answer. The data structure used in standard implementation of breadth first search is stack, queue, linked list, and your tree. You know, in your data structure, in your standard implementation of your breadth first search, always use the queue. That's why your answer will be a queue. Not a breadth first search will use the stack. Not a breadth first search will use the linked list in your standard implementation. Not use the tree. That's why your answer is your B, that is your Q. And next is that the breadth first search traversal of a graph will result into linked list, tree, graph with back edges, and your array. So the breadth first search traversal of a graph will result into your tree. That's why your answer will be a B, not a linked list, not a graph with back edges, and not a array. That's why your answer will be your B answer. You know, Another question is that a person want to visit some places. He start from a vertex and then want to visit every place connected to this vertex and so on. What algorithm he should use? Your depth first search, breadth first search, trims algorithm, and your crucial algorithm. So your answer will be your breadth first search, because in this question, a person want to visit some places and he start from a vertex and then want to visit the every place connected to this vertex and so on. So what algorithm he should use? In your breadth first search, you will visit the places, you will visit the all nodes, and you will start from a vertex and then want to visit the every connected node, every connected vertex, and so on. That's why your answer will be your breadth first search. And next is that, which of the following is not an application of breadth first search? Finding shortest path between two nodes, finding by partitioners of a graph, GPS navigation system, and your pathfinding. Your answer will be your pathfinding. And your object of this question is that following is not an application of breadth first search. That's why your answer will be your D answer, that is your pathfinding. And another question is that regarding implementation of breadth first search using queue, what is the maximum distance between two nodes present in the queue? And in this question, considering each edge length is your 1. So your first option is that your can be anything. Second option is that your 0. Third is your at most 1. And D is your insufficient information. So your answer will be your at most 1. Your answer should be your C answer. In BFS, how many times a node is visited? Once. First option is your once. Second option is your twice. Third option is that your equivalent to number of integrity of the node, and fourth option is that your thrice. So you know your answer will be your C answer. That is your equivalent to number of integrity of the node. That's why your answer will be your C answer. And in this lecture, I had discussed about how to insert the node in your binary search tree. And that is the purpose of this lecture. That's why in starting of this lecture, I had discussed about the object of this lecture and outcome of this lecture. In this lecture, your object of this lecture have to be fulfilled. So I hope you have to understood about how to insert the node in your binary search tree. And if we will talk about the summary of this lecture, so when you will insert the node in your binary search tree, so you will start always from your root node. Okay. If your inserted, if your new node value which you want to insert is less than from your root node, so your new node will always insert in your left hand side of your tree. And if your new node value is greater than from your root node, always your new node will be insert in your right side subtree. Okay, I hope you have understood about this lecture. Thank you.